In this video, we are going to talk about backward difference table. So we will construct the backward difference table for the given data points. Let's say we have 3 points data, x0, y0, 1 point. Another point is x1, y1. Another point is x2, y2. So this is an equally spaced data. That is the difference between every two consecutive x values is same all along the data. So to construct the backward difference table, we will put these data points in the tabular form. X, Y, X values are X0, X1, X2 and Y values are Y0, Y1, Y2. So to construct a backward difference table, we first calculate the difference between Y values. So we put an arrow between y0 and y1 and calculate the difference y1 minus y0. We put an arrow between y1 and y2 and calculate y2 minus y1. Now let's see what is the notation of y1 minus y0. If you can recall the backward difference operator, y1 minus y0 can be written as backward operator y1. See, backward operator acting on y1 is it stays at y1 and calculates the difference with one value behind y1, and one value behind y1 is y0. So we can see that the difference that we have calculated here, y1 minus y0, its notation is actually backward y1. And y2 minus y1 by definition is backward y2. You can see that it stays at y2 and then calculates the difference with one value behind y2, which is y1. You got two values, backward y1, backward y2. You put an arrow between them and calculate the difference. Always the second value, backward y2 minus backward y1. And now we have to see that what is the notation, compact notation for backward y2 minus backward y1. Now again, if we calculate, let's say, backward square y2, we want to see what we get. We will keep one delta out and one delta in. Backward y2. By definition, backward y2 is it stays at y2, calculates the difference with one value behind y2, which is y1. This is just the definition of backward y2. Now backward operator acts inside backward y2 minus backward y1. We can see that backward square y2 is actually equal to backward y2 minus backward y1. Let's look at this value calculated here, backward y2 minus backward y1. We can see that this is actually equal to backward square y2. So we can look at this table. We had xy values, we calculated our differences. So the third column will be named as backward yk, and the power on backward delta on every term in the third column is 1. Backward y1, backward y2. The next column, the fourth column, would be backward square yk. In this column, every term will be named as backward square and some y. Here there is only one term, which is backward square y2. Let's again have a look at the general form of this backward difference table. We have xy, x0, x1, x2, y0, y1, y2. Then we got the third column, backward yk. We calculated this difference and the notation of this difference was backward y1. We calculated this difference and the notation was backward y2. So if we know the notation of the first value in a column, then of course the second value can be named easily, because here if it's backward y1, the next would be backward y2. Then we got the fourth column, backward square. We keep on raising the powers in every new column on backward delta, backward square yk, and the first value that we calculated by calculating the difference backward y2 minus backward y1. It was named backward square because it's in the backward square column, and it turned out to be backward square y2. So it's a backward difference table. So these are the notations for terms in backward difference table. Let's actually get the backward difference table for the data. We have an equally spaced data 2, 4, 6, minus 1, minus 2, 7. So to construct the backward difference table, first I will construct the differences. Construction of differences is just like when we are constructing the forward difference table. So arrow between minus 1, minus 2, you calculate the difference minus 2 minus minus 1. Always the second value minus the first value. So it is minus 2 plus 1, which is minus 1. Difference between these two values, 7 minus minus 2 gives you 7 plus 2, which is 9. Difference between these two values, 9 minus minus 1, which is 9 plus 1, which is 10. We have constructed the table, but now let's name it. X0, X1, X2, Y0, Y1, Y2. Third column, backward YK. Fourth column, backward square YK. We have seen that minus 1 is actually the notation here for backward y1, backward y2. And in the fourth column, backward square yk, the value 10, its notation is backward square y2 actually. We have seen these notations here in the general table, that in the third column the first value is not backward y0 but backward y1, because here you are calculating the difference y1 minus y0, and in terms of backward difference operator, y1 minus y0 is actually the definition of backward y1. So that's why this first value in backward yk column is named as backward y1. So this is how we can construct the backward difference table. Let's quickly construct a backward difference table for another equally spaced data. We have 1, 3, 5, 7, 2, 9 y values. So construct the table, backward difference table. 2 minus 7, minus 5, 9 minus 2, 7, 7 minus minus 5, 7 plus 5, which is 12. Let's name it X0, X1, X2, Y0, Y1, Y2, backward YK column, backward square YK column. The first value in backward YK column is backward Y1. Next value is backward Y2. The first value in backward square YK column is backward square y2. So this is how we construct a backward differences table, and in the next video we are going to construct the polynomial using the backward differences method, forward differences method, and divided differences method.